In this video, I'm going to show you how to create the engineering drawing for part number 1 on our Intro to SolidWorks part modeling and drawing assignment. So our goal is to go ahead and create an engineering drawing like you see right here in the assignment. I'm going to move over to SolidWorks and I'm going to go File, New, same as hitting this icon up here. And this time I'm going to select a 2D engineering drawing by clicking on Drawing and pressing OK. The first option that's going to come up is to select a title block. Notice I only have 3 options in my title block selection right here because I've erased all of the other title blocks that you really don't need. I have provided us a title block file up on Polylearn. So if you were to download that file, I'm going to hit cancel for real quick. Come down here and notice you have an IME 144 SolidWorks drawing template .sld.drt file. That is a template file that will give you the class's title block if inserted properly into the template files in SolidWorks. To do so, you can the easiest way is to right click, copy that file, right click, copy, go back to SolidWorks. Underneath the sheet here you can right click and go to Properties, and when we're going to load a template file we could simply hit the Browse and we can right click and paste the drawing template into SolidWorks' sheet formats. Or you could go through SolidWorks, SolidWorks 2019, Language, English, and go to the sheet format file and just paste the file in there or save the file in there. But that's the quickest and easiest way to insert your custom template for the class into the template files. So now when I press Open, I'm able to select the 144 SolidWorks drawing template and I'm going to hit Apply Changes. Now you'll see we've got the drawing template or the title block ready to go. Also notice that it says Drawn by my name here. So I can't double click on the text box right here without editing the background sheet first. So what I'm going to do is I'm going to right click up on the title block in the middle and click on Edit Sheet Format. That allows me to change my title block. And I literally can double click now on my name here and type in my name. At this point, I'm done modifying my title block. If I needed to go back and maybe change my tolerances, I could double click in there, change those values for the generic tolerances for the drawing. But for now, that's all you really need to do. So I'm going to right click. And instead of editing sheet format, I'm going to hit Edit Sheet. This allows me now to go have a blank title block or a blank sheet. If I wanted to save my name forever in the title block format, I could go File, Save Sheet Format, and I'm going to save it as the same name. And now every time I bring up this drawing on my personal computer, it's drawn by me. At this point, we're ready to go ahead and insert views. So looking at the top ribbon bar, we have View Layout and Annotation. These are the 2 ribbon bars that we're going to use the most here in SolidWorks when creating engineering drawings. So when I click on View Layout, I've got 2 options right now. I've got a standard 3 view, which will give me my front, top, and right views, or I've got Model View. I prefer Model View because it allows me to get a pictorial view of the part as well as the standard orthographic projected views. So when I click on Model View, it brings open a window over here and allows me to hit Browse to select my part file from the location wherever I saved it last. So notice I'm going to pick the one with today's date, click on Part 1 Video Example, and click Open. At this point, it's ready to create a front view and place it on the screen if I click my mouse. However, I'm going to move over to the design tree over here. I'm going to actually expand it a little bit more by dragging my mouse button over. And I'm going to select Create Multiple Views. At this point, I want a front, I'm going to put a top and a right. I know the drawing doesn't have a right at the moment. I'm going to show you how to delete views as well. And then an isometric. And next, I'm going to come down to Scale. Scale is the size of the drawing in relationship to the actual part size. I'm going to hit use custom scale, and I'm going to go scale 1:1. At this point, I'm going to hit check mark, and you'll notice the 3 orthographic drawing views show up along with the pictorial view. Now let's move back to the actual drawing we're having you emulate and look at that. So notice the scale is actually incorrect in this assignment. I just realized that. It's actually a 1:1 scale, and then the pictorial view is a 1:2 scale or half scale. So what I'm going to do is I'm going to delete a view in SolidWorks, the right view, and then change the scaling ever so slightly. Also notice that the SolidWorks file does not have any hidden lines in it. I could have selected the hidden line option when inserting the views, but I'm going to show you how to change it directly on the views. So what I'm going to do is I'm first going to click on the orthograph or the isometric view. I'm going to move down on that view to the scale, and I'm going to hit use custom scale 1:2 or 1/2, and move that up into the upper right hand corner by clicking on it and dragging my mouse. Next, I'm going to get rid of this right view because you only need as many views as it takes to fully define an engineering drawing. So therefore, this right view here doesn't really give us any more detail than the front view can show us. So I'm going to go ahead and click on the drawing view and hit the delete key, which is going to ask me, do you really want to delete that view? So we're going to click on yes, and now we have our orthographic projections ready to go, minus the hidden lines. So at this point, I would like to go ahead and add hidden lines to my drawing. So I can click on the view, and there's 2 places to do it. I could do it up here in the display style, or I could do it over here in the display style. They're really same tool, 2 different locations. So I'm going to click on hidden lines there. I'm going to click up on this drawing view and click hidden lines there. Notice it adds the hidden lines for the holes in the front view and the hidden lines for this little protrusion on the bottom on the top view. Next, another type of line type that we want is a center line. We also want center marks, so I'm going to show you how to apply those. So I'm going to delete these center marks by clicking on them and hitting delete. So at this point, we're done with all of the drawing views. So we're going to move over to the Annotation Ribbon Bar, which gives us all the tools needed to fully dimension our engineering drawing. Now I mentioned we needed to go ahead and put center lines on the workpiece or on the front view. So I'm going to click on center line and realize there's an auto insert feature. I'm going to show you that, then I'm going to show you another way to insert the center lines. So if I hit select view, click on that view, it automatically adds the center lines where needed on the drawing. Sometimes though, that can get a little bit messy and you want to insert them manually. So what I'm going to do is I'm going to basically press escape, press Control Z, which is an undo function, and show you how to add center lines manually. In order to add center lines manually, you click on center line and you literally click on the 2 lines you want to put a center line in between. Like so. Now if you wanted to adjust the length that the center line extends past the visible line on the part, you can click on the center line to highlight it, then hold your mouse button down as you drag it. But by default, the center lines were spaced quite well. So I'm going to press Control Z. Whoops, it undoes that one. And just recreate a center line by clicking on the 2 hidden lines. At this point, I'm done placing center lines on my drawing. I now want to create center marks. So I'm going to click on the center mark tool. I'm going to click on the 2 holes and hit the check mark, and it automatically creates center marks. The one that I forgot is for this radius right here, this radius cutout. So I'm going to click on center mark, and I don't really want extension lines off of my center mark like you see right here. So what I'm going to end up doing is I'm going to click on Use Document Defaults and unclick Extend Center Lines, giving me a really small center mark that I can dimension to, and hit the check mark. So at this point, we've created all of the orthographic views, or the front and the top, along with the pictorial view or the isometric view, that's half scale. Also notice though, our drawing is changed to half scale down here. In order to modify that, we really want to show the scale of the orthographic projected views. Therefore, I'm going to right click on the sheet 1 setup, go to properties, and change my scale to 1:1. Therefore, the scale is correct on the actual sheet, so it matches the actual drawing, unlike the assignment I gave you. Sorry about that. Now, next, I'm going to go through and start dimensioning this drawing. So I'm going to look back at the drawing that you see right here, and I'm going to start placing some dimensions. The dimensions I'd like to place first are the 2.5, the 1.5, and then we'll place the 3.5. So to do that, we move back to SolidWorks, and we're going to use the Smart Dimension tool in order to create those dimensions across the part. So when I click on Smart Dimension, it works a lot like Smart Dimension does in the part environment. In fact, it works the same exact way. So what I'm going to end up doing is clicking on my first line I want to dimension to. I'm going to click on my next line, then I'm going to place my dimension. Now notice, the dimension should appear right between the dimension line in the ASME Y14.5 and ANSI standards. So that means I have a modified dimensioning style going on in my drawing. Remember, there's really two major dimensioning schemes out there. There's ISO, and then there's what SolidWorks calls ANSI, or its ASME standards. So to change your drafting standard, you can go up to the settings up here in the options in SolidWorks, click on Options, you click on Document Properties, and it says that it's set at ANSI, but really, if you go to ISO, click OK, go to Options, Document Properties, ANSI, press OK, it'll actually change. For some reason, it doesn't show ANSI dimensions right off the bat, at least on my install. So now you'll see that the dimension lies between the dimension line, just like the ANSI standards we learned about in class. So the next thing we're going to dimension is this protrusion down here. If I just want to dimension this one line, I can go from here to here by clicking my mouse button, or I can click on the single line and just drag it down and place the dimension. Now let's go back and look at the actual drawing. You see we have the 2.5, the 1.5, and I forgot to place the 3.5. So let's go back to SolidWorks and use our Smart Dimension tool, which is still active, and go from this edge to the center mark like you see right there, and place the dimension. Now remember, the dimension, the amount of decimal places that the dimension states, will relate to our tolerance here in the title block. So if I needed to change the amount of decimal places on a dimension, I could click on the dimension and change from the default settings of 2, which is what I have set as my default. So I can go all the way down to tenths, but we're not going to get that accurate in class. So we're going to be accurate to the thousandth. However, the drawing shows 2 decimal places, so we'll just copy the drawing at this moment. So when you look at it, we've created the 3 linear dimensions here. We're going to go back to our drawing, and we're going to create the 2 heights like you see right here, the 0.75 and the 1.75. So when I move back to SolidWorks, I'm going to use datum dimensioning for this one, just show you the differences. I could pick, they call it baseline dimensioning. I introduced it in class as datum dimensioning. But we click on baseline dimensioning, and the first thing you click on is your datum or your baseline. Then the next line you click on, it places the dimension. If I wanted the top one, I click on the top one, and it uses the first selection or the first datum as the 0 point that it references the dimensions off of. When I press Escape in the tool, I could easily click on a dimension and drag it out, or move it if I needed to. I can move it up or down or drag it. Whoops, press Control Z there. Now, we've got the 2 dimensions. Realize you don't have to use baseline dimensioning if you don't want to. Whoops. And I'm going to hit delete, you can do pretty much everything with Smart Dimension if you really needed to for the linear dimensions. Remember, I could click from here to there and drag out, and I have my 2 dimensions placed. Now, Smart Dimension will also dimension radii. So when I click on the radius, it knows that I've got not a full circle, therefore it gives it a radial dimension with the R in front of it, and I'm allowed to place that dimension. Now, I believe this view is fully defined compared to the drawing that I gave you. If you look at it, we've got all those dimensions placed. So let's work on the top view. The top view has the holes located and then the overall thickness of the part. So let's go ahead and create that, or dimension that view. So when I move back to SolidWorks, I can go from this edge to that center mark and drag it down. Now, I believe it said 0.375 on our assignment. Therefore, I highlight the dimension, I come over to the design tree, and I change it to 3 decimal places. Next, I'm going to go from here to here and place my dimension. Now, my 0.375 is in the way, so I'm going to press Escape in that tool. I'm going to drag it out this direction, like you would see back on the drawing right here. Now, my last dimension in the x-axis, technically it's the x-axis, is this 4.75. So if I move back to SolidWorks, I can literally just click on the line with Smart Dimension, move down, and place that dimension. Finally, I've got to give the hole location in this direction by clicking on that edge and that edge, dragging it out. And then the overall thickness of the part by going from that edge to that edge and placing the dimension. Now you'll see we've got extension lines and dimension lines. There's a small visible gap between the extension lines and the actual visible lines on the part. You know you've clicked in the right location if you have that small visible gap. The final dimension we need to place on this drawing is the hole size. Really, they're both the same size, so I'm going to end up just clicking on this hole, dragging up, and remember, holes get dimensioned by their diameter size. So if you notice, we have 0.5 diameter. Looking back at the drawing, you'll see we've got 2 by 0.5 through. You don't have to write through on the drawing. That's kind of an older optional thing. It is assumed a through hole if it doesn't have a depth symbol with it. So I'm going to show you how to write through anyway and put the 2 by on the actual hole. So moving back to SolidWorks, I can click on the dimension, and down here by the dimension text, you'll see it says mod DIAM. That's going to be the diameter symbol it places in there, and the carets are the dimension it pulls from the solid model. So if I wanted to go ahead and put 2 by in front of the diameter symbol, I click my mouse button on the dimension text and I type 2 uppercase X space. Notice the engineering drawing I gave you in the assignment has a space between the X, which really it's 2X and then a space. I added an extra space again. So a couple revisions here or there. But when I move back to SolidWorks, you'll see I've got to add through. So I'm going to click on the dimension, go back to this dimension text, press space and write THRU. Because all lettering on an engineering drawing is an uppercase lettering. At this point, we have a fully dimensioned engineering drawing. It fully defines the part. We'd be able to build this part in our lab if we really wanted to. Or draw it by hand, like we did in the orthographic projection practice. However, the one thing that's not finished on this drawing is the material, the title, and the date. So I place notes on my engineering drawing to specify the material, the title, and then the date. So moving back to the other drawing, it's going to be IME 144 SolidWorks Intro to M&D number 1. And then the date that we have created the drawing. And then the material that we're making it out of. So moving back to the SolidWorks file, I click on Note. I come down here to the title. Now notice Note will leave a leader if you click on an edge, or if you don't click on anything, it'll just create a text box for you to type out Intro to SW and D number 1. And then you click off it to end the text box. Now it keeps that same note, but I'm just going to literally click into material and it highlights everything. So as soon as I start typing 6061-T6, which is an alloy of aluminum, a very popular aerospace alloy, spacebar, aluminum. Materials engineers and the students who take the material science class will learn all about the different alloys of aluminum and how they're designated. Now last but not least, I want to put the date down here, and it's first day of the quarter, 9/19/19. All right, and I click my mouse button, I press escape in that tool. So we've created the first engineering drawing for your Intro to SolidWorks modeling and drawing assignment. I'm going to now go to File, Save As, and I'm going to go ahead and save it as the Part 1 video example. You should save it as your last name, M&D number 1, or however you want to save it, because technically you're just turning in the engineering drawing hard copy. So when I press Save, it saves that engineering drawing. Now let's say you don't have a printer that's hooked up to your SolidWorks. What are you going to do? We'll save it as a PDF. So in order to save your engineering drawing as a PDF, you can literally go File, Save As. We can click on PDF, and then we could save it as a PDF. Now you can send your drawing to anybody in PDF form. In fact, you could save it on your smartphone to show it off to your friends, or send it to your mom to check out, or dad. So anyways, that's the first Intro to SolidWorks modeling and drawing assignment. Hopefully you enjoyed this video tutorial. Join me for the next video tutorial to learn how to do the second part for this assignment. Have a great day.